we can't avoid in the C language is when a function uses a pointer as its argument, or a function may return a pointer. This condition occurs frequently with C library functions, so what does it mean? The function -10 is prototyped at line 3. It requires a pointer variable as its argument. A pointer variable stores a memory location, so it accepts a pointer variable directly or the address of any variable, and that's the secret. You pass either a regular variable prefixed by the ampersand or an initialized pointer variable. Here, the address of variable value is passed to the function in line 10. The ampersand operator fetches the address. In the function, the asterisk operator is used to change the value of the variable passed. Build and run the code. The variable value is affected by the function even though only its address was passed and the function didn't return anything. The value is manipulated directly in memory. In this code, pointer function longer requires 2 character pointers as arguments, and it returns a character pointer. Character pointers are strings, and you see 2 declared here at lines 8 and 9. The result pointer is initialized by the value returned from the longer function at line 12. The longer function starts at line 18. It's declared as a character pointer function, meaning it returns an address as a value, specifically the location of a character or character array stored in memory. Within the function, the lengths of the strings are compared. The address of the longer string is returned. Build and run the code. And the longer string is displayed. This code shows how a string can be manipulated within a function. Because pointers are used, the string isn't returned as a value. The shouting function at line 19 takes a string and munches through it 1 character at a time. Each character is run through the toUpper function, which converts lowercase to uppercase. Build and run the code. Type some text such as, "I'm not shouting." Press enter. And it all worked without returning anything from the function. In this code, the encrypt function accepts a character pointer or string as its argument, and it returns a character pointer, a string. The original string is unchanged, so a new string is returned from the function and displayed at line 10 in the printf function. Build and run. You may see a compiler warning, and it's a serious warning which explains how the output is unpredictable. In this case, the output says null, which means that somehow the pointer was lost in memory. And here's the warning. The problem here has nothing to do with pointers, but rather with variables used in a function. Those variables are local to the function, and their values are discarded when the function returns. This rule holds true for the output character buffer shown at line 17. To fix the problem, you must declare that that variable is static or unchanging. The keyword static directs the program to retain the variable's value when the function terminates. Save this change. Build and run. With a newly built string saved in memory, you return its address, and that address still references those characters encrypted. So the problem here really isn't the address coming back from the function. The problem is that the data referenced by that address is lost when the function returns. The static keyword retains that data, not the memory location that references the data. This concept may be puzzling, which is yet another reason why pointers are dreaded and avoided by many C programmers.